This is weekly contest 296 min-max game. So we are giving array with index 0, which they guarantee that the length is a power of 2. It means it always will be divisible by 2. And then they ask us to apply the following algorithms, that when n is the length of the nums, if n equal to 1, then end the process. So when the membership of the nums array that was given as an input become 1, that's when we are stopping. Otherwise, we will need to create a new zeroth index, new nums, of the length just half of it. Okay, just half of it. And we also guaranteed that it is divisible by 2, so it will be okay. Then for every even index, then for 0 up to n to divided by 2, we assign new nums as min of the 2 times it or the 2 times it plus 1. For every odd, we do the other way around, which is max between the 2 times I and compared to the 2 times I plus 1. After that, we replace the nums with new nums and we repeat all the process until the termination criteria where if n equal to 1. And then the question is, let's return the last number that remains in nums after applying the algorithm. So this one is an easy problem. And if you see this problem just now, let's talk about the tactic. The tactic itself is pretty easy, which is just translate all of this into a program. And they make it easier because everything is guaranteed to be a power of 2. So later on, whenever we dividing this into half of it, we can just use an integer division, or you can use floor. In my case, I will use integer division. So let's translate it. So this is the code implementations. Well, if we want to see the example, it's pretty much, this is an example. The last part of it become 1. The first one is we'll take, what you call it? The first one is, if you remember, we will loop through it, right? And for every index I, we will compare it 2 times I plus 2 times I plus 1, which is means at index 0, we will compare 1 and 3. And then we'll take the mean, because 0th index is an even number. It's considered as an even number. So taking the mean, we get the I. Then at the first index number 1, it means 1 compared to 1 plus 1, which is 2. So 3 compared to 2. And then we will take the max because index 1 is an odd. That's why we took the 5. Then index 2. Index 2 meaning we compare index 2 and index 2. At index 2, actually we are comparing index 2 times 2, which is index 4, 0, 1, 2, 3, 4, and see index 4 plus 1, which is 8. And index 2 is an even number, so we took the minimum, which is 4. After that, the last point is we detecting index number 3. 3 times 2 is 6. 0, 1, 2, 3, 4, 5, 6. So we compare between index 6 and index 6 plus 1, 7. And we took the max. And the same problem times, it will be true. And then we do the same thing now, but starting from these nums. And at the end, we will get 1. Okay, so let's do the code implementations of it. The code implementations is basically as simple as we use the termination criteria, which is when we keep in as long as the length of nums is greater than 1. When length of nums is equal to 1, it becomes the termination criteria when we will return the first index of the nums. And we can see that in the constraint, it is guaranteed that at minimum we got a length of 1. So we don't need to take care of the edge case when there is a 0 membership of nums as the input. So this is the key points of the terminations. And while the length is greater than 1, remember that the problem telling us to divide it into 2 with that min-max rules. So we prepare the next nums here as an empty array, and then we loop through a range of index from 0 to half of it. Notice that we are using integer division here, and this is fine because they are guaranteed that the length of nums always is a power of 2. In other words, it is always being able to be divided by 2. And then if this is the checking whether it is an even or odd. When I modulo 2 equal to 0, this is another saying that this is an even number index. When it is an even number index, remember that we use the mean of nums 2 times I and with nums 2 times I plus 1. And then we just need to append it because naturally it will be already in the right index order to be represented later on into the next nums. While the else part means it is an odd number. When it is an odd, the difference only in the replacing mean with max. After that, we reinitialize nums into next nums all the way until len nums is no longer greater than 1. That's the point when we return the last standing numbers. So if we use the sample code here, we run it. Let's check the things. It's correct, right? And then we submit this and it is accepted. So that's it for the first problem of this weekly contest. Thank you for watching.